All right, point slope form day 2. So this time, as we move on with point slope form, we're going to learn how to write an equation in point slope form when I'm given 2 ordered pairs. So rather than being given a point and a slope, I just have 2 ordered pairs to go from. So let's take a look at an example. So if I have 2 points on a line and I'm asked to write an equation of that line going through them, so going through these ordered pairs 2, 5, and 8, 6. So let's say I have a graph and I have an ordered pair of 2. This is going to be a really messy graph. 5, right? And 8, 6 would be somewhere over here. And I want to write an equation of a line that goes through those 2 ordered pairs. Well, I could graph the 2 ordered pairs, right? And I could draw a line through those ordered pairs and see where it might intersect that y-axis. But again, I'm not always clear that that line is going to intersect the y-axis at a friendly spot, right? Now we know that's not a great line, but just go with it. So if my y-intercept is right here, now that's not a whole number. It's not a friendly place for that line to go through. So what can I do? All right, so let's see. Remember our point slope form, y equals m, or slope, times x minus x sub 1, which is the x value of an ordered pair, plus y sub 1, which is the y value of an ordered pair. So I actually have multiple choices when I write this point slope form of my equation because I have 2 points to use for the x sub 1 and y sub 1. But what am I missing? What don't I have? I don't have the slope. I'm not given a slope. Well, can we find a slope? We know slope formula, right? We know that m, or slope, or rate of change, is the difference between my y values compared to the difference between my x values, or rise over run, right? We know that rise is your y values, right? So I have y minus y sub 1, and you may write this in a different way, but the basic idea is it's the difference between your y values and the difference between your x values, right? Okay, so there's our slope formula, and we have the information we need for that. We have 2 ordered pairs. So I could do 5 minus 6, right? Those are my y values. Make sure, again, that you're using your rise or your y values on the top. Well, if I used 5 first, then I'm going to need to use my 2 first for my x's, right? So I have 2 minus, right here, 8. Which means our slope is 5 minus 6 is negative 1. And 2 minus 8 is negative 6. A negative divided by a negative is going to give me a positive slope. So I have a slope of 1/6. Right, let's double check that. 5 minus 6 are my y's. 2 minus 8 are my x's. Negative 1 over negative 6 gives me positive 1/6. So again, I said I had 2 options then for writing my point slope equation. Right, so here's my first option. Well, now I have my slope of 1/6. So this really is just one additional step of finding your slope and then using point slope form. Now I have my x minus x sub 1. Well, I could start with this ordered pair of 2, 5, right? So I have x minus x sub 1 is my x value from my ordered pair that I'm given. So my x sub 1 is 2. So x minus 2 plus my y sub 1. So my y sub 1 from this ordered pair is 5. So there's one point slope form that I could use. Y sub 1 is 5, x sub 1 is 2. But I have 2 points. Now if these 2 points are on the same exact line, then I should be able to use either one of them in my point slope form. So my other option then would be y equals, again, same slope, the same line, so it must be the same slope, is 1/6. I have x minus x sub 1, so this time my x sub 1 is, for my other ordered pair, 8, right here. So x minus 8, and my y sub 1 is going to be 6 this time. So plus 6. Right, so like we said, these should be an equation for the same line. Maybe that doesn't make sense. How can I have two different equations for one line? Well, you could double check in your graphing calculator by putting these equations in, right? So we're going to do just that. So here's our graphing calculator. Let's start with this one. So I am in function mode here. I forget how to go to function mode. So there's mode right here, right? Go down to there, and that should say function. Then I'm going to go to y equals, and I'm going to go ahead and put in my equation. So there's my first 1/6 times x minus 2. X is right here. And plus 5. Right, so there's my first one. Let's go to graphing. So I'm going to graph that line. Okay, there's my first line. All right, let's go back to y equals, and let's go ahead and put in that second function, that second equation, in y sub 2. So again, same slope, 1/6 times x minus 8 plus 6. Right, so it looks like a different equation, different values. Let's go ahead and graph this. If these equations are the same, if they represent the same line, then I should only see one line when I graph these. Oops, I accidentally hit second. Didn't mean to do that. There was my blue line. Red line is graphed right on top of there, which tells me that these equations are exactly the same. I'm going to go just one step further to show how these equations are the same. And what I'm going to do is I'm going to simplify those two equations. Right? So if I use some distributive property and combine my like terms, let's see what I get. I have 1/6 times x, so 1/6 x. Again, I'm just using distributive property. I have 1/6 times -2, so that's going to be -2/6. And I could simplify that to 1/3, right? And then I have plus 5. Okay, well, I have to simplify this -2/6 and positive 5. In other words, 5 minus 2/6, or 5 minus 1/3. So 5 minus 1/3 is going to be, again, I'm just simplifying this portion right here because these are like terms. So 5 minus 1/3 is 4 2/3. So you can see that when I simplify this, what form of an equation do I have? I no longer have point slope, I have slope and intercept. So I can see my y-intercept is 4 2/3. So when I simplify a point slope form of an equation, I end up with slope-intercept form. And I can go ahead and then see what my y-intercept is. Well, again, let's just simplify this one and see what we get. So again, using my distributive property, 1/6 times x, 1/6 x. I have 1/6 times 8. I'm going to go ahead and simplify that right away. So that's 8/6, right? 1 times 8, 6 times 1. So 8/6 is going to give me, and that's minus, right? Right, so I have 1/6 minus 8/6, which is going to be 1 2/6, or 1 1/3. And then at the end here, I have plus 6. So I have to do a little bit more simplifying, right? I have some like terms right here. So I have 6 minus 1 1/3. Well, 6 minus 1 is 5. Minus another third is 4 2/3. So just like in my last equation, I have 1/6 x and a positive 4 2/3. So we can see when we simplify into slope-intercept form, I end up with exactly the same equation. So those are indeed equations of the same line. So one other thing you might just want to jot down in your notes. So we already did this. We checked those by graphing them on our graphing calculator, as well as jot down, please, in your notes. We can also check them by simplifying into slope-intercept form.